Hello, my name's Gabe. For this problem, we're asked to evaluate the surface integral of f of xy ds, where f is y plus 5, and the surface which we're integrating over is given by the vectored value function ui plus vj plus 2vk, where u is between 0 and 1, and v is between 0 and 2. Now the idea we're going to use in order to evaluate this integral is given by this up here. So what we're going to want to do is we want to rewrite the surface integral as a double integral over some region D. And the way we're going to do that is we're first going to find x of uv, y of uv, z of uv, and then we're going to go ahead and find the magnitude of the cross product of the partial derivative of r with respect to u with the partial derivative of r with respect to v. So let's go ahead and let's actually write down what x of uv is, y of uv is, and z of uv is. So looking at our vectored valued function, we see that x of uv is going to be u. We have y of uv is v. And we have z of uv is 2v. So now that we have these three explicitly stated, let's go ahead and let's find the partial derivative of r with respect to u, the partial derivative of r with respect to v, and then find the cross product. So this partial derivative of r with respect to u is just going to be I. And the partial derivative of r with respect to v is going to be j plus 2k. So now that we have these two, we can go ahead and we can find the cross product of the partial derivatives of r with respect to u and the partial derivative of r with respect to v. So this is going to be the determinant form of this, whose first row is I, j, k. The second row is going to come from this partial derivative of r with respect to u, which is just going to be 1, 0, 0. And this third row is going to come from the partial derivative of r with respect to v, which is going to be 0, 1, 2. Now let's go ahead and let's find this cross product. So for the I part, we're going to have 0 times 2, which is 0, minus 0 times 1, which is 0. So we're going to have 0i. Here we're going to be subtracting, for the j part, 1 times 2. So we'll have 2 minus 0 times 0. So 2 minus 0 times j. And for the k part, we'll have 1 times 1, which is 1, minus 0 times k. So what this tells us is that this cross product is equal to negative 2j plus k. So now that we have our cross product, we can go ahead and we can write down the magnitude of this cross product. So let me just do that right here. So the magnitude of the cross product of RU with RV is equal to the square root of negative 2 squared plus 1 squared. So this is going to be the square root of 5. So now we have all of our pieces of information. Let's go ahead and substitute all of this into this equation up here. So we're going to have our double integral, and the region that we're going to be integrating over is going to be given by u and v. So let's integrate with respect to u first. So u is going to vary from 0 to 1, and v is going to vary from 0 to 2. Now this function which we're going to be integrating, this f of x of uv, y of uv, and z of uv, well, we're going to come over here and look at how our function was defined, and we're going to replace y with y of uv, which in this case is just v. So we'll have v plus 5. And we already found the magnitude of this cross product, which was just the square root of 5. And as I said before, we're going to integrate with respect to u first, and then with respect to v. So we see the square root of 5 is a constant. Let's pull that out in front of both of our integrals. So we have the square root of 5 times the integral from 0 to 2. And let's at the same time evaluate the integral of v plus 5 with respect to u. So this is going to be uv plus 5u. We're going to evaluate this from u equals 0 to u equals 1 dv. So in doing this, we'll have the square root of 5 times the integral from 0 to 2. Substituting u equals 1 in, we'll have v plus 5. And when we substitute u equals 0 in, we'll just have 0. So our integrand is just going to be v plus 5. And we're integrating with respect to v. So what we're left with is the square root of 5 times v squared divided by 2 plus 5v. And we're taking this from 0 to 2. So if we substitute in 2, well, we're going to have 4 divided by 2, which is 2, plus 10. And if we substitute in 0, this is going to be 0. So what we're left with is the square root of 5 times 12. Or we can write this as 12 times the square root of 5. So what that tells us is that this surface integral is equal to 12 times the square root of 5. Thank you.